The standard Big Bang model assumes the universe is isotropic, meaning it should look and rotate the same in every direction. But recently, the James Webb Space Telescope analyzed the earliest galaxies in the JADES survey and found a preference that shouldn't exist. 2/3 of those galaxies spin clockwise. This global bias toward one direction is a signature the standard model has no way to explain. To find the source of that rotation, we have to look at the geometry of the event horizon. These images show the boundaries of the most powerful objects in the cosmos. In the Unzipping Horizon model, we are currently existing inside one of these, the interior of a rotating black hole, where the spin of the parent environment is physically imprinted on our own spacetime. This starts with a single unified mathematical object called a quaternion, the seed state. In this state, before space or time emerged, all 4 degrees of freedom were bound together. It represents the total information of the parent black hole's boundary, compressed into a single, highly structured geometric point. This suggests that reality began not as a chaotic explosion of matter, but as a precise geometric blueprint waiting for the right mechanism to break it open. The mechanism triggering this process is the fold operator. It acts as a mathematical blade, forcing the unified seed state to unzip and divide. Having the seed creates a permanent divergence into a measurable real branch and an orthogonal imaginary branch. This triggers a recursive loop, building out a vast fractal binary tree that expands at every tick of cosmic time. The blue left section is the real branch of classical spacetime, terminating in particles we measure with light. The gold right section is the hidden imaginary branch. It bypasses photons but exerts gravitational weight, providing the source of dark matter. What we perceive as the universe is merely the observable side of this equation. The invisible scaffolding of the imaginary branch is what provides the structural support for everything we see. When the tree fractures over a 3, 4, 5 Pythagorean triangle, the sum of the sides exceeds the hypotenuse, creating a 2/7 remainder. This predicted 28% imbalance perfectly matches the Planck mission's dark matter measurement of 26.8%. If reality is an ongoing fracture process, we have to look at what governs the pace of the construction. This model redefines the universal speed of light, c, as the literal mechanical clock speed of the ongoing unzipping. It measures the rate at which the black hole's horizon generates new fractures and adds new leaves to the tree. The universal speed limit is absolute because nothing inside the interior can move faster than the rate at which the interior itself is being built. These microscopic fractures leave a signature on the largest scales of astronomy. To see it, we now return to the James Webb Space Telescope and that mystery of the early galaxy rotation. In a sample of 263 early galaxies, 66% were found spinning clockwise. This 66-33 split suggests the entire universe was born with a preferred handedness. The unzipping ball traces this bias back to the rotation of the parent black hole. Because the parent is spinning, its angular momentum imprints a subtle tilt onto every single imaginary branch during the fracture. These tiny geometric tilts accumulate across billions of nodes to create a global cosmic axis. This coordinated twist is what forces whole galaxies to rotate in a single preferred direction. This model makes specific, testable claims. It links the rotation of galaxies to the horizon's geometry, so we can look for corresponding phase jumps in Earth-based laser interferometers. If our universe is unzipping, our equipment should detect the rhythmic pulse of the refresh rate. We are discovering that the universe is an active, ongoing boundary process. We are not just observers of the cosmos,